Hello.
Hello.
Yes, audible.
Yeah, hello, good evening. So today is we'll take week 11 activity and practice assignment question. So let me share my screen. Okay. Uh, Anybody has doubt in week activity 11.1? First question, second, third, fourth, fifth.
Fourth question. Sorry, fifth. Hello.
Yes, sir. Question number 5.
Okay. So question number 5 is that so question number 5 is that PMF is given and now we define from PMF, right? So you can consider, let's say this is a success. y value 1 as success, right? So now random variable y has two values, 0 and 1. It as like x is less than a or x is greater than a, something like that, right? Now in this, they are asking where a belongs to a positive integer. Uh, for what value a Bernoulli trial of y be considered as the most uncertain, right? So most uncertain Bernoulli trial, right? So the variance of Bernoulli is p into 1 minus p, right? So this is the variance of Bernoulli. And and that's what like the most uncertain, right? So when uncertainty is high, when variance is high, right? So that's what they mean, that we want this value to be high. So when this value will be the highest, actually what you can do is you can take derivative of this value, like p minus p square. If you take, let's say, derivation of this, you'll get 1 minus 2p. And from this, like if you make it 0 to get a maxima or a minima, right? So um, this is a little bit integral, but to get a maxima or minima, you have to set it to 0. And from this, you can get that p is equal to 1 by 2, right? So when p is half, that's when the variance will be highest, right? The maximum variance you can get when p is equal to half. So that's what they are asking, that make this random variable in such a way that x less than equal to a or greater than equal to a, the probability is half, right? So y, if you draw this like let's say 0, 1, then p of y should be like half and half, right? So if this happens, uh, then uh, then this condition satisfies, that whatever a value, right? So we want to find a value such that this thing can happen. Okay, so how are we going to do? We want something which is less than this. So summation we can see, right? Let's say summation, if we do 0.1 plus 0.2 plus 0.2, which is still here, then you can get that this is 0.5 and this also 0.5, right? So here it is the distinction, right? So from this you can say that the value they are looking for, x less than equal to a, right? The value they are looking for is 3, right? A is equal to 3. So whenever a is equal to 3, then this thing can happen, and this will leads to the highest variance. Okay.
Yes, sir.
Okay. Anything else?
No, sir. Got it.
Okay. Um. Okay. 11.2. Anybody has doubt? Okay.
Yes, sir. First two, three. Can you please explain this question? Are you? I am audible, sir. Hello.
Yeah, you are audible.
Hello.
Yes, sir. Hello.
Yeah, you are audible.
Yes. 11.2, sir. Question number first.
11.2.
Okay. Yeah.
Okay. 11.2.
Cumulative distribution function. This question first. CDF, sir.
Yep. Uh, so
For following CDF.
so let's say you have PMF, right? Something. Uh, what you do is you add all the probabilities less than that value. Okay. So let's say PMF is like this. Let's say
PMF
if
and
this values are
CDF also are you same? Both are same, yeah, different.
They are different. That's what I'm. Wait for some time. Okay, let me explain it.
Okay, I am with.
So let's say this is 0.25. Let's say this is 0.5, and this is also 0.25. Okay, and let's say this value is 0, 1, 2. Okay, so this is x, and what I'm mentioning here is like probability of that x, right? So this thing like this. So 0, 1, 2, when x value is this, then you write p of x, right? So at 0 it is 0.25. Let's say 1 it's 0.5, and then 0.25, right? So this is PMF. How do you get CDF from this is you sum it up, like whatever that value is. So let's say now you draw again. So here 0, less than 0, we didn't have anything, right? So you can say less than 0, it's 0, right? So 0. Then from 0 to 1, this value is there, right? So summing up of this 0.25. Then from 1 to 2, so now 1 to 2, it's going to be a bump of this, right? So what is this value going to be? Is going to be 0.25 plus 0.5 from this, right? So summation on, and finally you will have 1. So this is how you get the CDF. This is CDF. You sum the probabilities less than equal to that value. So here they, when they are saying that less than 0, x less than 0 is 0, means this, right? Then from 0 to 1, this is the probability given. From 1 to 2, it's they've given this. So they are saying 1 to 2 is this means 1 to 2 is this, right? I mean, uh what they did is, yeah. So if you see, if you want to, this probability, if you want to find uh from CDF or something, uh what they are saying is they have added p of x equal to uh this one of x equal to 1, right? So these two values they have added, and they got this value. Okay, less than equal to 1, and sorry, greater than equal to 1, and x is less than 2, this plus this. So that's how they got this. Okay, so summation is the PDF. Now this was the explanation of CDF. Find this values, right? So what is the value of n? How will I do that? I will do that using, I mean, it's given, right, that how many are there, right? So let's say if it was any kind of distribution, they've given us that x, whatever x value x can take the values, right? That it can take 0, 1, 2, 3, 4, or 5, right? So and they have given this probability is not given to us. They've given us this CDF thing, right? So we can't actually find this thing easily, like we can subtract out each of them, but from this we can get it that n is equal to 5. This all values are given, that the last is 5. So from this we can say that n is 5. How are we going to find the probability of p, right? Something. So for that you have to take any of this. So generally you can take, let's say, first or last, which is easy, like p is uh, y- you should know that what is binomial random variable probability. How we can find is uh, that is the way they mentioned is like n c, or like k, or should I use, let me use k, right? So k times you get something, then what you do is probability is power k, and then you can say 1 minus p power uh, whatever left, right? N minus k. Like this is the formula of probability of finding a binomial random variable thing, right? So whenever you want to find a probability, so in this case you can maybe say thing, right? It's p power x 1 minus p n minus x, right? Something like this. And what's happening is like 1 minus p they have mentioned as q. Okay, so this part is not good, but that's how a formula is. Okay, like this. So this is the formula, and you want to find p uh, of this. So what you can do is you can, right. So when x value 0, that if you do in this formula, and n value 5, right? So 5c0, which is actually 1, right? Then 0 time. Uh, can you do it? No, that this is not the better option. The other way around, like you can take this guy for last one, because if I write p power 0, then you'll get 1, right? So you'll not get p value. So but you want to find p. So what you can do is, no issue. So formula was ncx p power x q power n minus x, right? So this was the formula, and we are taking this one to find it. So 5c5, okay, and then probability is going to be something which we don't know, power 5, because x is now 5 and q is, you can maybe write 0, and anything power 0 is 1, so we don't need to worry about that. 5c5 is also 1, so p power 5 we got, right? So p power 5 is equal to this one, 3124 divided by 312. 5. Did I get that? Mm, uh, something is missing. It has to 0, 1, 2, 3, 4, 5, and 2 q power 5 is going to be 10245 3125. This is okay. Uh, this would be right. From this, you can say q is uh, okay. Sorry. So yes. Uh, this is okay. Yeah, sorry. So I was mentioning that this is, you can write q is equal to 1 minus p. Okay. So we can actually find q thing, that is easy, and then maybe you can say p is 1 minus q. Okay. So both is uh, okay, right? So we can do that. So 5c0, p by power is going to be 0, and q is q power 5, right? So this thing we can write this thing 10. q5 is equal to this, and you have to take q equal to this power 1 by 5, right? This thing if you do, then you will get the answer. So from this you can get q, and p you will get using 1 minus q thing. Okay, so this is how you will get both of them, p and q.
Okay, sir. 11.5, sir. Question number first three. Have 6, 8.
Hmm.
11.5.
Yeah, wait. Any doubt in 3? 11.3. Okay. 11.4. Anybody has doubt? Okay. 11.5.
Yes.
Okay, which question?
First number, sir.
First. So binomial
Binomial, right?
random
Yeah.
variable is given, right? So what is the uh, mean of that, like, or expected value of this?
Variance.
What is the expected value of binomial random variable?
5.9. Oh, sorry, 5.4.
But what is that 5.4? Like, I mean,
Mean,
uh,
no? Binomial variable
just
mean.
forget about this. What is binomial random variable expected value? Like, what? How will you uh, how will you give in formula or something like that?
That's in time of probability.
Huh? You you do this right? What is this value going to thing? Summation of this, right? Same, and not xpx, summation of this, right? So how will you find this for binomial? What is the value of this for binomial thing? Uh, that is, so expectation of binomial renewal is n times p. Okay, and this is given 5.4. N is also given, so you can find p from this 5.4 by 9, correct? And variance is n into p into 1 minus p. So if you put this values like 9, this whatever 5.4 by 9 is, I think 0.6, and this is 0.4. So if you do this, you'll get this value, variance. Variance is n for binomial. Okay, so that's how you can solve this. So if you solve this, you will get the value. What? Okay. What is the next question?
3, sir.
3.
Yeah.
3. Okay. Also, so first, so if you want to find p of x equal to 3, means what they are asking? They are asking that n, c, or whatever this n value is. So first we need to find n, right? So you should know n, then only you can do this. Otherwise you can't do it. How will you find? From this you can find it that um, this is 6, right? Yeah, this is 6 given here. Okay, and 1 minus p is 33.6. So from this you can say p equal to 0.
So it's 0.4, I guess.
1 minus 0.6, which is 0.4. Okay, so 0.4 is the p, and NP is 6. So how will you do it? So N you have to find, right? So 6 divided by 0.4, correct? So if you do this, this is 6 divided by 4 into 10. You can do it like this, right? So this is 3, this is 5, so 15. So this is the right answer. 15, N is 15 and P is 0.4. So you want to find for 3, right? So how will you do it? 15C3, 0.4 power 3, 0.6 power 12. So this is the answer of this. You have to solve this. Okay.
Excuse me, sir.
Yes.
Here in the formula of finding the probability of the binomial random variable, the n means the total number of trials, right?
Yes.
Okay. And what does here that you are choosing? I mean, if we consider in the formula that NCI or NCX,
Hmm.
whatever, what does
Yeah.
X stand?
X is how many successful event.
Okay. Like here we choose 515C3. So 3
Yes.
here means a successful event, right? Out of 15.
Yes. Correct. Where success
Okay.
appeared, right?
First,
So when we do Bernoulli, we get success or failure, right?
yes,
Something
sir.
we get
Yes, sir.
either success or failure.
Yep.
Yeah.
Okay.
Success or failure,
Got it,
right?
sir.
So when we write binomial, we write like this. So we get 3 times success. So this is how we do it, and then we find the probability of if it's a failure, uh, like let's say 2 times something, right? So
Okay. So one thing I wanted to ask you is that in the instructor session,
hmm,
one topic was there that expectations of sum is equal to sum of expectations.
yes.
Yeah, actually at that point I wasn't justified with the explanation. So could you please explain it for me?
I mean that is the statement, right? That
Yep. That's a statement. I was not getting what exactly it wanted to say.
expectation of X plus Y.
Sorry, sir, your
Uh,
voice fumbled.
okay. Hello.
Yeah.
Hello.
No. Yes, sir,
Is
it's
it
all right.
okay?
Yes, sir. Totally.
Okay. So just let's say take one thing is there, mu1, which is 9. Let's say mu2 is 8, right? Now if I
Hmm.
ask you, let's say these are 5 numbers, okay? These are
Yep.
6 numbers. Fine. Now if I
Yes, sir.
ask you, what will be the mean of this 11 numbers? This 11 numbers. How will you do it? Mean of this 11 numbers if I ask you. So 5 number mean is given. 6 number, different 6 numbers, mean is given. How will you find the mean of both of them or total of all of them? How will you do that? So one thing you can do is you can write like 9 into 5 plus 8 into 6 divide by 11. You can do that, right?
Yep.
Yes, that is
Ye-
okay.
Yes, sir.
Yeah. So uh okay. Now if you see um yeah, so this was mean of first one and this was mean of second one, and I can write like this, right? Yes, right. So yeah, so this is how you can also write the mean of this, right? And actually, what is the expectation? Expectation is probability into so p of x into x, right? So maybe you
Yes,
can
sir.
consider this as x and this as px, okay? And this is also x and this as px. So if in different kind of things are there and their expectation is given to you, you can just sum the expectation and you can get it. Okay, so this is the property of uh the thing.
Okay, sir. Got it.
Expectation, right? Even
Yes, sir.
variance also have it if they are independent event. Like if they are not independent x and y, then you can't independent random variables. So x and y has to be independent. Then you can sum them up.
Okay, sure. Okay, sir. Thank you. Got it.
Okay. Okay. Anything in this question number 4, 5, 6? Oh, still there. 7, 8. Okay. 11.6. Any doubt in 1, 2, 3, 4, 5? Okay. 11.7.
Sir, hypergeometric problem 11.7, sir.
Yeah,
Sorry.
11.7.
Yeah, question
So
number 3.
question number 3
Yeah.
here. Okay. So
No, sorry. Question number 4, sorry. Yeah.
here, this one.
Yeah.
Okay. So you have 250 green apple and 250 red apple, right?
Yes.
A customer comes to Sumit's shop to buy apples and select 5 apples. Okay, so he will select 5 apples of this. Okay, without replacing, of course, like he has to pick all of them. Okay, so five of them. If the random variable x represents the number of green apples,
Total, no, sir. Both are green and red. 500, 500 rupees.
yes, yeah, total is 500. Total is
Yeah.
500, and out of 500, he picks 5. So if
Yes.
the random variable x represents the number of green apples, so green apples he is talking about x as number of green apples. Okay. Green apples in the selection of 5 apples. Okay. Then find the variance of x. So variance of x you want to find. So variance of this thing you call hypergeometric random variable, because why this is hypergeometric random variable, because in Bernoulli or binomial, what happens is success and failure, the probability doesn't change, right? So Bernoulli is just one time event. Like you pick one, if you would have picked one apple, then I could have think of Bernoulli, but he didn't, right? So I can't. And let's say if it was binomial, in this case, what happens is it has to be identical and independent uh, distribution, right? Identical independent distribution should be
Yes.
there. So this is also not happening, because in first time when I pick the apple, let's say if pick green apple, the probability of green is this thing, uh 500, sorry, divide by 500. Then on second event, it's happening 249 by 500. Let's say if I pick again green or something else. So but basically probability is changing because I'm doing without replacing them. So I want to find this probability. So one thing I can do is can I know what is hypergeometric random variable variance, how to find variance of this, right? That n into m by n into 1 minus m by n, or somewhere it will run like n minus m. Somewhere it's written like n minus m by n. Okay, this is also same thing. And then I think it was n minus 1 by n minus small
It's
n.
what? N minus a small n upon capital N
N
minus,
minus,
I guess, 1.
yeah, minus 1, right? You can, so capital N minus 1 divided by n minus small n, right? So you can directly apply this formula, because you know what is n. N is 5, right? 5 we are going to pick. What is going to be M. Uh,
I think it's
okay.
the green apples.
Yes, yes. Number of green apples. So it could be 0, 1, 2, 3, 4, or 5. Right? All five of them are green. So you have to mm, oh, no, wait, sorry. Yeah, number of green apples, I mean 250. M is 250. Okay, M is 250. Not this value is not this. M is 250 and capital N is 500. Sum of both of them. And yeah, so this way you can do it. Uh, you can find this. Or another way you can do is because there is one formula or one statement that says if the small n, right, the small n, uh, if the small n is very small than n, right, or something like this, then you can directly apply binomial theorem. You can directly apply binomial and you will get the answer. So in this case, this condition is actually satisfying, right? Because 5 is kind of very small than 500, right? So how much it is? It is if I do, it's like 0.01, right? So something like this proportion it's there, right? If it is like around 5%, then you can consider it as 5%, right? So this is 0.01%. If it was around 5%, then also this formula will hold, right? This that you can directly apply binomial and it will hold. You can do that. And if you do directly with binomial, it becomes easy. So variance is going to n into p into 1 minus p. Just you need to find what is p, right? So probability of picking a green apple, which is half, and 1 minus p is also half, and n is 5. Yes, small n only. Yeah, so 5 into half. If you do, then you'll get the answer. So whatever this is, it is the variance of this thing. Okay. Half, half multiplied by 5. You can do that, or else you can do this. Both will get almost similar answer. Okay. Up to 2 decimal accuracy, yes, that will be satisfied. Okay. Okay. Any doubt in 11.8? 1, 2, 3, 4, 5. Okay. 11.9, 1, 2, 3. Is that together? Yes. 2, 3. 4, 5. Anything in 4, 5?
Yes, sir. Can you please explain this question 4-5? The
Okay.
Poisson distribution.
Okay. 4, 5. So they are asking how to solve this, right? So first you can find what is p of x equal to 2 of Poisson, right? So how will you do this? You do like e power, so anything, right? E power minus lambda. So
E
let's say
power minus lambda.
e
E
power
power
minus
x.
lambda power x and divided by x factorial, right? So they are
Yeah.
asking for x equal to 2, that is e power minus lambda power 2 divided by 2 factorial, right? The same way you can do it for x equal to 1. So if you do this, like 3 into e power minus lambda square by 2 factorial is equal to 6 into e power minus lambda power 1 by 1 factorial. Okay, so if you solve this, um, this will get cancelled. Here you will have 1 lambda, and so lambda is equal to 6 into 2 factorial, which is 2, and by divided by 3. So if you do this, you'll get 4. So lambda you'll get 4. And what is variance of or what is the expectation of Poisson? So Poisson have expectation and variance both are same, which is equal to lambda, right? So from this, I can say that v of x is like this thing we know, right? That variance is this part. So if I know this value, which is lambda, I know this value, which is like e of x is lambda and square of that lambda square. Then I need to find this guy, right? This one. This is being told to us. So lambda I know 4, right? So here minus. So 4 square is 16. This is 4. So what I'll get is 4 plus 16, which is 20. Right. So from this I can say that this is going to be 20. And variance is lambda itself, which is 4.
Sir, 60.
Because of this, right? Square of this 4.
So acceptance of variance, this formula apply.
Yes, yes. This variance formula, right? This variance formula is there.
Acceptance of x square minus acceptance of the whole square.
Yes.
Find the value. Oh, suppose okay. This is
I mean, I know
acceptance
this. I know this.
of
So I can find this. Right?
yes.
So lambda is 4. I know what I know is v of x is e of x square minus e of x
Whole square.
whole square, right? This thing I know. So I know that in Poisson, v of x is equal to e of x. I know this, which is lambda. So this I know lambda. This I have to find, and this is lambda square, and lambda value is 4, right? So from this I can bring this here, which will make 4 plus 16, which is 20, right? So this is 20 and this is 4. Variance equal to lambda. Fine.
We can
Yes, okay, fine.
we can also do it this way, right? Like in case we do not remember this formula, then we can do it basically. We can say that x square equal to 4. For x square equal to 4, my probability should not change, correct? So e of x square should be x into probability of x of 4. So that way also it could be essentially be done, isn't it?
E of x. Sorry, what you are saying? E of x into 4.
So x, basically when x is equal to 2, my probability is whatever, like some number. So when x is equal to 4, the probability never changes, right? Like how we derive it, like e of x square is basically x. We say that x equal to 4 at that time, what is the expectation, right? Hello.
Hello.
Yeah,
Hello.
yeah, I can hear you. So
Yeah.
yeah, I was basically referring to the very naive way of solving this, like how it was derived, right? That ex square minus ex is equal to variance. So that is what I was referring to. But anyways, we can move on. That's just another way that I thought. I'll try to solve it that way, but first.
Okay. Okay, fine. Practice. Okay. Okay, and out in 1, which is okay, 2. 2, yeah, 2 you can do it. They are asking n equal to 4, right? So till 4. Okay. You don't need to solve all of them, right? Because see, if you solve, let's say, first one, and they're saying x equal to 0, then probability is 0. That is not true, right? Some probability will be there, like let's say 4c 0, and then when p power 0 will be there, and then 0.3, right? That is q, or 0.7 power 0, 0.3 power 4. So some probability will be there, right? So this can't be true. You can figure out this one, which is looking like actually 3 by 10 power 4, right? So 3 power 4 is 9 and 81 by 10 power 4. So something like this. This thing looks like it, right? Then you can maybe figure out what are the different choices given. So this and this and this cases are looking to be maybe correct, right? So now you don't need to solve for second one, which is already both are same. Third is also same. Fourth is also same. So just need to figure out what is the last one, right? So which is 4c4 p power 0 point not I mean 0.7 power 4 and then 1, right? That power 0 is going to be. So if you solve this, if you get this one, you can choose or this one. You don't need to solve all of them. The variance is given, probability is given, then find the CDF. So same thing, like you can find CDF for when it is from 0 to 1, right? So 4C0 guy you can find. So any one of them, or I think all three of them are same thing. So you don't need to find. I mean, you know that. What you know is that how many. Oh yeah, I think you need to find what is n going to be, right? So n you can do it if it is binomial. You know that v of x is n into p 1 minus p, right? Which is given to us 1.2 and p is 0.6. So this is going to be 0.4, and from this you can find the n. It looks like 24 by 100. Right. So n is going to be, this is 2, 10, 12 into 10 by 2. Okay. 60. No, can't be 60. That will make it to 0.6, 0.4 is equal to 1.2.
A quick question though, do we really need to find this n value here? Because f of x is what? It's like that probability mass function, right? That is given there here.
But here,
No,
see,
it is
it's
not. It's
going
not
till
probability
4.
mass function.
There somewhere it's going somewhere else. Like here also it's going till 4. Here it's going till 5. So how will I know? Is it should be 4 or till 5?
So when the x is given, then it's always starts with less than equal to, I mean greater than equal to,
Yeah.
right?
Okay.
Uh, so so x includes, like, that value, the lower limit value is to be included and the higher limit value is to be excluded. Now what I see in here is this is basically given a cumulative function. It's already given, because otherwise how can that one be for the last? That's what I'm not understanding.
How can last be?
Yeah, see, the summation of all the probability has to be one, right?
Yeah.
Probability mass function if given. Now
Yeah.
in this option, one
This
is
can't be there.
correct. One is given, like, for the fourth option, the last x is greater than equal to 5, it's given 1. So,
Hmm.
right, so that option cannot be there. Then 4, then the second option, which you have
No,
basically,
this can be there, right? This can be there. This is CDF.
this is a
This is
CDF,
CDF.
right? In the question,
This
it
is
says
CDF.
that find the cumulative distribution of x. When the CDF is already given, then why it is asking to find the cumulative distribution?
CDF is not given. CDF is the options. So this 3 options are CDF. You have to find the valid one. So is it
Okay,
this
okay,
one
okay.
the valid or second or third valid? Which one is the
So
valid one?
Correct, correct. Okay, so all we need to do is just find the probability mass function for each range, and then make sure that they are adding up to 1. Correct?
You can do that, but you just need to find which is correct, right? I mean, you don't need to solve all the PDF or all the PMFs, right? You don't have to find. What you can do is you can see till which value the n is going on. Let's say I think 4 or 5. So here 4 is there. So this one can't be there. So second option, this because it's not going till 1, right? It has to go 1 if it is CDF. So either
Correct,
A
correct,
is true or C is true in this case.
correct.
And if I see yeah, so I need to figure out maybe this value or if I even find n value, then I think it's solvable. If n is going to be 5, then this is the value. If n is going to be 4, um then also this doesn't look like to me, because what is after 4, it's not given to us here, right? I mean, so like you can straightforward say that this is the right answer. You don't need to find n. Yeah, you don't need to actually, because
Correct, correct.
greater than 4 is not given here, and here it's not adding up to 1. So yeah, you don't
Exactly.
need to find it.
Right.
Uh, okay. Now, which of the following? Okay, fourth, any doubt? Fifth one, sixth question. Okay, seventh,
Yes, sir. 7th, 8th.
seventh, eighth. Okay, fine. So
The probability Python developer.
so so seventh one, right? So the probability that a Python developer writes a code without an error is 0.98. He makes those errors randomly. Okay, making an error in each line of code is independent of other. He writes a code of 100 line. What is the probability that he makes exactly one error? So first thing is, how will you know that this is a question of binomial, or let's say hypergeometric, or a Poisson distribution? Like which kind of distribution they are talking about? Because if they are talking on length or something, then it's kind of
Independent.
saying that it looks like they are maybe Poisson something. In Poisson,
Poison is
also.
like for a
Yes, yeah,
yeah,
go ahead.
yeah, I was saying that poison is like whenever your space and time is limited, only then that's the catch of poison,
Yes,
right?
yes, correct. Space and time limited given it. So here also given 100 lines. I mean, space or one line is there, right? So line is kind of space you can consider.
Correct, correct.
So, but still it's going to be binomial.
Correct.
Um,
It's looking to be a binomial because in that what happens is your number of instances in the poison for a given time duration becomes like very, very large, isn't it? Like,
hmm.
uh, but in here, the number of instances is n is equal to like 100, like, it is specific, like, there are 100 lines and
Yes. So,
error is in
uh,
each line only.
yeah. And one thing is, in Poisson, lambda is kind of average, right? Mu or lambda, you can call it. So something about average is given. Let's say something is happening averagely in this period of time, averagely in this space of time. Sorry, in this space. Then this average kind of thing is given to you, and then they will ask what will happen exactly at some value, like how exactly two errors can be made, how exactly people can enter in 2 minutes or something, right? So or less than, greater than could be also there, but they have given you something related to average. Okay, but here average is not there. What is given is there writes a line of code without error. So they've given us the probability itself that something without error or something, right? So 0.98. Then they're asking that those errors he makes randomly, which is okay. Make an error in each line of code is independent. So now they're talking about independence also, right? Uh, in in Poison we don't talk about independence or something, because actually we don't care. We care that in this space or period what's happening, right? We don't care about independence or something there in Poisson distribution. But here we are talking about independence. Now he writes 100 lines. So something like n kind of thing you have to think that what is n could be, or what is going to be uh the space they are talking about. So I mean, like, it looks like independence and all is there. So it is going towards binomial. Then if they mention something like n kind of thing, then you can probably find the answer, right? So n is, he writes 100 lines of order, so 100 is the n. Then what is the probability that he makes exactly one
Sir,
error?
n means numbers of selecting, no?
Not select number of this experiment can happen. So making error is one time thing event, right? So one error he can make, any error, right? So any error he can make at a probability of uh, without. So this is without error. So uh,
Yeah,
he
this
makes
is the
those
without
errors
error 0.8, 0.98.
that he makes exactly one error. So let's say error making probability could be 0.02, right? This is what he makes. And if he keeps on going on in a line of code, right? So line of code is the you have to see that if he writes a line of code, he makes error. The probability is this. If he writes 100 line, then you can maybe see that 0.02 into could be 100, right? So uh, this could be the many mistake he can make in 100 lines of code, right? Uh, but if in 100 lines of, but they are asking what is the probability that he makes exactly one error, right? So that's what they wanted to ask about. So n is given to us 100, and p is given to us that making error. Okay, so here success or something is 0.02, or actually making an error is the success criteria. Okay, then they are asking what is going to be the value of I or k x, whatever you take. Let's say when is exactly equal to 1, right? So this is what you have to find out. So 100 c1, he makes exactly one error in any of the line. 100 lines are there, he can make error in any of the line, right? So we have to take combination. Then p, what is this, is 0.02 power 1 and 0.98 power 99, something like this. Okay, if you solve this, you'll get the answer. Okay, fine.
Okay, sir, fine. 8 number, sir.
Okay. A school teacher has six different color, marbles of six different colors. All six colors marbles are equal in portions. Okay, he gave 18 marble to each student in a class. If Vijay is a student from the class and he likes blue marbles, what is the probability that he would receive less blue marbles than he expected? Getting blue marbles equal for all the trials. Okay, so since they mentioned equal of this, that then you can even consider that it's not going to be something with related to hypergeometric at least, right? Because when multiple items are there, if you want to pick different items or something, then the more likely question could be hypergeometric. But then since they mention all are equally likely, then there is no point in going to hypergeometric. Now it could be binomial. Okay. Uh, so let's see. A school teacher has yeah, so six different color marbles. All six colors are equal proportion. He gave 18 marbles to each student.
In the
Eight,
classes.
six different, all six color marbles are in equal proportion. Okay, some proportion is there. He gave 18 marbles to each student. Okay, so each student got 18. Let's say there are multiple students. They all got 18. Vijay is a student from the class, and he likes to color. He likes blue color marble. Okay, so someone is there who likes blue color marble. Uh, what is the probability that he would receive less blue color marbles than he expected? Uh, okay. So what first thing is what he would have expected, right? That is the question, right? What would have Vijay expected, that how many color marbles he would get if they are his, right? So uh, I mean, let's say they are all equal, then he would have expected that he would have also received equal number of all the marbles, right?
Total color
Uh,
24.
Sorry,
Six
total.
color, yeah, 6 color is equal this marble color.
Yeah, so 18 are there, right? So six different color marbles are six. All six marbles are equal proportion. So let's say if 18 are there, how will it going to 3 into 6, right? 6 3 is 18. So each color marble. So let's say first color marble should be 3, another should be 3, 3, 3, 3, and 3, right? So now he got less than 3 of any one, right? Let's say blue, sorry, this blue one, right? So he got blue as less than 3, right? That's what we wanted to find the probability of, right? So so first thing is getting a blue colored marble. What is the probability of getting a blue colored marble? How are we going to do that?
3 by 18, right?
3 by 18, right? That's what it is. Or you can say 1 by 6 from here itself, right? All six colors are there, and I mean they are in equal proportion, right? Equal proportion, all them. So you can directly 1 by 6 also. You
Correct.
can do that way. So this is success. Failure is 5 by 6. Okay, failure or not getting 6 is this. Now they are saying that what is the probability that he would receive less than the marbles he has expected? So he has expected 3 marbles, right? That's what he would have expected it. That he would have got in equal proportion or something, right? So what we have to find is it. Uh, he would get maybe 0 or 1 or 2, not 3, right? More than 3 is also okay. So this 3 things you have to find. Uh, Basically, you have to find 3 out of 3 marbles.
5 by 6.
Sorry,
This is a 5 by 6 blue.
why 5? Oh, 5 by 6 is failure. Means he doesn't get the blue colored marble, right? That is 5 by 6. Yes. So okay. Yeah. So this thing we have to find out. So x equal to 0, 1, or 2. Um, but what is going to be the n, right? That's what we have to figure it out. And um, we are going to do 18 times, right? I mean, see, let's say success, success, success means he got 3 marbles, then all are failure, right? This is what could be there. So if this is the case, then that is the normal event. He got 3 exactly. We want him to not getting any success, right? I mean, first case is 0, so he got all the failures, right? So how will you find the probability of this? You multiply failure probability by that many number, right? That's why you do it. So 18 is the n, and you want 0, 1, or 2 of them as a binomial, and then you have to sum it up, right? So we got that n is equal to 18, p is equal to 1 by 6. From this also you can get, or 3 by 18 is also you can do it. Expectation, actually you can do it n into p if you want. Same thing, right? 3 you will get. So how will I do it now? So n equal to, sorry, when x equal to 0, I'll write 18c0, 1 by 6 power 0, 5 by 6 power 18 plus 18C1 1 by 6 power 1 5 by 6 power 17. Then one more entity 18C2 1 by 6 power 2 5
Sir,
by
excuse
6
me.
power 16. Yes,
Which formula apply? Can you please formula?
this is
NCR.
binomial.
Yeah.
Binomial, or you can directly multiply as well. But you have to do this you I mean combination also you have to consider, right? Anything could be let's say success, right, out of 18 events. Here this one event is success, so let's say success, then all the failures, all of them 18, or could be like f first is failure, then second is success, right? So this is also there. So different way it can happen. uh
Okay.
since there is all the have like independent and all, right, because there is uh all marbles are equal proportion and all. Okay. And here it's mentioned that equal for all the trial, so you don't need to worry about that, is it a case of hypergeometric or no. Okay, question 9, question 10, 11.
But sir, answer is not correct. This process. Can you please? Question number 8.
Question number
It's
8.
and sorry, 9.
9. Okay. 58% teenagers in India play online games. Okay. More than 3 hours. Okay. More than 3 hours. More than 3 hours. Some 58% plays it. Okay. Assume this surveys is true for current population area. 40 teenagers are selected at random from this population. Let X be a binomial random variable, which represents the number of teenagers who spends more than 3 hours in playing online games. Find the standard deviation. I mean, this is straightforward binomial, right? You just see standard deviation. You can do if you know variance. Variance is n into p 1 minus p. What is p? Uh, who spends more than 3 hours, right? So this is what we
3
have to
hours.
find out, and it's given that p is 0.58. So this is 1 minus p is going to be 0.42, right? Then n is 40. 40 is given to us. That 40 times with this trial will happen. So if you do this, you get under root of this is standard deviation, right?
Suppose standard variance then n minus
Sample variance, sorry.
n standard variance. Suppose this question. Find the standard variance, not find the standard
This is
deviation.
standard. This is
Standard
variance.
variance.
This is variance only.
Okay.
N p
Only
1
this
minus
formula
p.
variance.
Standard deviation is under root of variance.
Okay. Okay, sir. Thank you.
Okay. This is standard deviation. Okay. For binomial, okay, 10th. Anybody has doubt in 10th? 11th, 12th, 13th, 14th, 15th, 16th. No, this is, yeah, 14, 15, 16. So here it's mentioned correct, but this 3. Okay. Okay then. That's all. Does anybody has doubt in solve with us? What is it? Okay. Anybody is out in this? Yeah. Solution is also given. So if you haven't done that, if you haven't solved, you can maybe see the solution later on. Anybody has question in 3 or anywhere like in this? You have solved this.
Sir, question weightage 9 to 12, 75%, no?
Yeah, or 60-70% you can consider. Not exactly 75. You can consider higher 70 with a 70-60 higher weightage will be given to the 3 to 5. Sorry, 9 to 12 week. Okay. Okay, I think there is how many are there? Okay, I think there is no. That's not. Okay then. That's all for today's session.
Sir, can you please previous term question paper?
Sorry.
Previous term, in term exam question paper,
Yes.
which side available?
We will release the mock. We'll release the mock soon. So this mock will be available here, right, for end term.
Okay. Previous term exam, in term exam, the not question paper available.
Yeah, we don't have that. I mean, we share the we only release mock only. So mock will be available to you.
Okay.
Okay.
Okay. Sir.
Okay then. Yeah. Goodbye, everyone.
Thank you, sir. Good night.
Yeah. Thank you. Good night.